angles and how we can graph angles for trigonometry, and then also another way to measure angles. When we graph an angle in trig, we're going to have what's called an initial side. We learned at the beginning of the year that an angle is defined as being two rays with a common endpoint that we call a vertex. One of those rays we're going to call our initial or starting side, and then the second side we're going to call the terminal or the ending side. When we graph in what's called standard position, which is how we are always going to graph or draw our angles, the initial side is going to be our positive x-axis, so straight out to the right, and the origin will be our vertex of our angle. To draw an angle with these measurements for the first one, what we start with is our x and y axis. Then I said standard form begins the angle straight out to the right. Now the margin of your paper, doesn't matter how many, doesn't matter how big, but just draw a few circles. Nope, just kind of off in the margin of your paper. Just draw a few little circles. Just kind of doodle some circles. As you are doodling those little circles, how many of you draw your circles in a counterclockwise direction?
Wait, which way?
Counterclockwise. So opposite direction the clock goes. Most people do. I don't know why it is. It doesn't even seem to be a right-handed or left-handed thing. It's just that most people draw your circle around counterclockwise, which is how we're going to graph our angles. So it's kind of handy that it works this way. So around our circle, going in a counterclockwise direction, how big is each quadrant? 90 degrees. So up at the top, we would have 90. Halfway around, 180. Down at the bottom, we'd get 270. And if we go all the way around the circle, we'd have 360, or 0 to start. So if I want to go 210 degrees in a counterclockwise direction, starting from that 0 line, I'm going to go past the 180 and land somewhere down here. How much past the 180 did I go?
45 degrees.
For 210.
30
degrees past the 180. 210 is 30 more than 180. So I'm going to go to the 180 and I'm going to go 30 degrees past that. So when we graph an angle, we have a few parts to it. We have our x and y axis. Our initial side starts at the positive x-axis. We need the little arc, the arrow that shows which direction we went in, that we're going counterclockwise for this angle. We need our ending side, and we need a number that tells us how big this angle is supposed to be, because I'm not going to make you use protractors and rulers and do precise measurements here. So we have to put that number in there so that somebody looking at this knows how big we meant that angle to be. That number should always go next to the closest horizontal, next to the closest x-axis. It is true that 210 is 60 before 270, but for where we are heading with this, that's not helpful. We always need that number to be next to the closest horizontal or x-axis. So for the second one, for negative 45 degrees, what do you think I'm going to do differently to graph a negative angle? Go backwards. So we're going to go clockwise. We start in the same place, but we're going to go backwards for negative angles. So we're going to go clockwise 45 degrees. Again, you need your starting and ending side. You need your little arrow that shows which direction we went in. And then we need a number that says how big that angle is supposed to be. It's supposed to be 45 degrees. For the last one here, 510. 510 is more than a whole circle. Right? How big is a whole circle? 360. So what we're going to do is start at our 0 line and go around once with a spiral to cover 360 degrees. Then how much more do I need to do? How do I figure that out? Subtract. So I've already done 360. How much more do I need to do? Another 150. So from here I'm going to go around 150 more. And how far away is that from the horizontal?
150.
It's It's 150 away from 0. How far away is it from the closest horizontal? 30, because that horizontal line is 180.
Does it matter which one you go? Like, you do the other?
We always want to use the closest x-axis. So we want that number to be acute. All right.
So basically, we're basing this that every angle is 90 degrees, and so yeah, doing what's left over in the quadrant.
Yes, every quadrant is 90 degrees, and so then we're thinking about what's left over until we get to that closest horizontal line.
Okay.
All right, go ahead and try graphing the next 3 of them then. These for negative 120. We begin by drawing our x and y axis, starting where we always start, straight out to the right. In which direction am I going to go? Clockwise backwards for the negative angle. And it's going to land somewhere about here. And what number do I need to put into the graph? 60 away from the 180. It is true that it's 30 past the 90, but for where we are heading with this, we always need our number next to the closest horizontal line. So we want to say that it's 60 away from making it to the 180. For 400, 400 is bigger than a full circle. So we begin with a spiral around, and how much more do I need to do? An additional 40 degrees. And for the last one, 350, we start in the same location. Positive angle, so we go around counterclockwise. And we land just a teeny bit before 10 degrees before making a full circle. Questions on graphing angles?
Now, do we have to do this, like, exactly, like, for our homework or no?
What do you mean by exactly?
Like, do we have to, like, graph it, like, do it precise?
Graph it just like this. You don't need to be precise with like a protractor and a straight edge and stuff. Just that's one of the reasons why we put that number in there, is so you know that I meant that angle to be 40 degrees, even though it may in fact not be 40 degrees. So just kind of these sketches are good.
If we put both numbers, like from how far away it is from like 90 or 180 or whatever, would that be okay, or do we have to find just the one number?
If you put both, that's fine, but make sure you at least have the one that's next to the x-axis. So if you also put the 30, that's okay, but make sure that you definitely have that one next to the x-axis. All right, if we did not include as much information in our pictures as I told you to, you might get confused about what an angle was supposed to be. So if, for example, I graphed negative 60 degrees, I'm going to go on backwards, 60 degrees, but if I didn't tell you that I went backwards, if all I did was said that it ends up there, 60 degrees away, you wouldn't know whether I meant to actually go backwards 60 degrees, or whether I had gone forward around 300 degrees, or maybe I went backwards more than once, or twice, or 3 times. Maybe I did some spirals in there. So if all you show me is where it ends and not what happened to get there, we call those coterminal angles. If we break that word down, co means together or with, terminal means ending. So they're angles that end with each other or end in the same location. Doesn't matter what direction they went or how many times they went around, but they end in the same place. That only happens once every circle, because that line only exists that one time in the circle. It's not the same anywhere else. Everywhere else there'd be something different. So how big is a circle? 360 degrees. So to find coterminal angles, we are going to add and subtract circles to our angle, or add and subtract 360 degrees. The drawings say that we need to have one positive and one negative answer. So I'm going to begin by, for the first one, adding 360 degrees. That gives me 300, which is a positive answer. Positive and one negative angle. So I'm also going to subtract 360 degrees, which would give me negative 420. So what this means is, If I graphed negative 60, the original question, and my two answers, 300 and negative 420, they will end at exactly the same spot. Right? Their directional arrows would be pointing different, but they would all end at exactly the same spot. For the next one, we could begin by adding 360. That would be a totally valid way to find a positive answer, but what do you notice about 495? It's already bigger than a circle. So if I start by subtracting 360, I still get a positive answer. So I need a negative answer. How am I going to get to a negative answer? Subtract again. You can add and subtract as many times as you want or need to until you get to a positive and negative answer.
Wait, minus 360 from 135.
From your last answer. Yep. Just continue adding and subtracting 360s. You could technically add 7 360s, and that would be a correct answer. You could subtract 12 360s, and that would be a correct answer. I'm going to ask that you don't do more than necessary. Go to your closest positive and negative answers, because that's the answers I'm going to give when we grade our homework, so that'll just be easiest. But it is correct to add or subtract 360 as many times as you feel like it. Okay, so we add and subtract 360 until we get to one positive solution and one negative solution. And the original question doesn't count as a solution. Okay, so I had a lot of students asking, well, can't I just count negative 60 as my negative answer? No, that's the question. We need two answers, one positive answer and one negative answer. Okay, so go ahead and try the next one. In both of those, add and subtract 360s as necessary to get one positive and one negative solution. Good. I'll begin by adding 360. That gives me positive 260, which is my positive solution. And then I will subtract 360, which gives me negative 460, my negative solution. For 575, I could begin by adding 360. That would be totally valid. That would be a correct positive answer. But since this is already bigger than 360, I'm going to start by subtracting. So it gives me 215, which is still positive. So then I'm going to subtract again. If I can get the screen to cooperate. And that gives me my negative solution of negative 145. Okay, so add and subtract 360 as necessary to get to one positive answer and one negative answer. Questions on coterminal angles? You don't need to graph them as well. You can do it without graphing. But if you would graph them, they would all land in the same place. Our final topic for today then is radians. Radians are another way to measure angles other than degrees. So we've been working with degrees a lot, 180 degrees in a triangle, 360 degrees in a circle. But there's another way to measure angles that's called radians. Kind of like when I measure the length of something, I have a lot of options. I can do inches, feet, centimeters, meters, miles. Lots of options for length. We have a couple options for angles. A radian is the size of the circle it sweeps out. What does radian sound like? Radius. So what we're going to do is take a circle and say that that circle has a radius of 1. By the So what we're going to do is say, like we were graphing angles, let's start straight out to the right, and then as I move around the circle and make an angle, kind of like opening a hinge, I'm looking at part of the edge of that circle, or part of the pizza crust. And the radian is how much of the pizza crust do we have. When we talk about the edge of a circle, what is that called? Circumference. What is the formula for circumference? Pi radius squared is area. Pi times the diameter, or in terms of the radius? What is the diameter? It's twice of the radius. So 2 pi times the radius is our circumference. So if our radius of the circle is 1, then our circumference is equal to 2 pi. So if I went all the way around the circle, I would say I had gone 2 pi. So a full circle is 2 pi radians. Okay, a full circle is defined as 2 pi radians. How big was a full circle in degrees? 360 degrees. That means that 2 pi radians must be equal to 360 degrees because they're both talking about a full circle. Kind of like if I take a ruler is 1 foot and it's 12 inches, so 1 foot must be equal to 12 inches because they're both defining the same thing. Okay? Since both of those numbers are even, to simplify our calculations, we're going to divide them both by 2. And instead of saying that 360 is equal to 2 pi, we're going to say 180 is equal to pi. So when we convert back and forth between degrees and radians, we're always going to use pi being equal to 180 degrees. Just like we would say 12 inches is equal to 1 foot. So to perform these calculations, you're going to begin with the number I give you. If it is not a fraction, I decide how to set it up is I put what I'm given on the bottom. So since I'm given degrees, I'm going to put degrees on the bottom so that they'll cancel each other out, which then puts pi on the top. It's always pi and 180, and we decide what goes where so that what we're given cancels. So in this one, I want degrees on the bottom so they cancel. Then when we multiply fractions, we multiply straight directly across. This isn't an equation, so it's not cross-multiplying. It's just multiplying fractions, so it's multiplying straight directly across, and then reduce for your answer. So our final answer is going to be 11 pi over 18. No decimals. Keep the pi in there. Just reduce that fraction down. So 110 degrees is equal to 11 pi over 18 in radians, just like changing measurements of length. For the second example, begin with what they give you, which is already a fraction, so I don't have to make it into a fraction. So I'm always going to multiply by 180 in pi, and I set it up so that what I'm given cancels. So in this one, I'm going to put pi on the bottom, which puts 180 on the top. So pi's cancel, and I get negative 180 degrees divided by 9, which is negative 20 degrees. So we always use 180 in pi, multiplying so that what we're given is on the bottom, so it'll cancel. Questions?
Where's the 180 come from?
180 degrees is equal to pi radians. That's our conversion, just like 12 inches is 1 foot. So it'll always be 180 in pi. Go ahead and try these two. For the first example here, start with what you're given, turn it into a fraction if it's not 1. So I put it over 1. I'm going to multiply always 180 pi, and I choose 180 on the bottom of pi, so that we'll cancel with the degree we're given. Multiply straight across, it's not a cross, multiply straight across the top, straight across the bottom, so 320 pi over 180, and reduce, so 16 pi over 9. For the second one, start start with what you're given. It already is a fraction, so I don't have to make it one. Put what you're given on the bottom, so this time pi on the bottom with 180 degrees on the top. Pi's cancel, and then I multiply straight across like we did last time. Negative 5 times 180, and I'm going to divide that by 12. And I can plug that in negative 75 degrees. Questions? I have a few more examples for you that are not printed on your sheet, but we need to talk about them because there are ones like this on your homework. So what we need to do is revisit the first couple topics we talked about, graphing angles and coterminal angles, but looking at what happens when we're working in radians instead of working in degrees. So we talked about how to graph. We said when we graph or draw an angle, we're going to do so on an XY axis.
This is what negative and positive.
Coterminal angles is the negative and positive. So now we're going to graph our angle. First type of question that we looked at. So we said we're going to start on our positive x-axis. And then when we had degrees, we could just kind of work with the 90s that are there and figure out where we're supposed to land. But radians are going to be a little different for us. 180 degrees is pi radians. That was the conversion we were just using. How much of a circle is 180 degrees? A half of a circle is 180 degrees. So we want to take half of our circle equal to pi. But in this question, I'm looking at pi over 7. So what I want to do is cut that pi, or half of a circle, into 7 pieces. When you are cutting into odd pieces, that vertical line is not going to help you. So I want to cut each half of the circle into the number of pieces the denominator says, because half of a circle is pi. So, oops, I have my eraser on still. 2, 3, 4, 5, 6, 7 pieces on the top. They should be equal pieces, but, you know, I'm not being picky about this because it's kind of hard. So then also 7 pieces on the bottom. So 2, 3, 4, 5, 6, 7 pieces on the bottom. So there's 14 total pieces going around the circle. Since pi is 180, that's half of a circle. 7 pieces. Cut each half of the circle and the number of pieces the denominator says. Then number of pieces. So we want to go 3 of these pieces from our starting line, and that's where we end. You do not need to include on these the little number that says how big that angle would be. Okay? So that's what we're going to do here. Cut each half of the circle into the number of pieces the denominator says, and then count around that many pieces. 7 pieces on each half, top and bottom, and then we count out 3 of those pieces, and that's where we land.
And the pi doesn't matter.
The pi represents half of the circle, so that tells us that half of the circle is breaking into 7s. For negative 3 pi, what's the denominator there? 1. So I want each half of the circle to be 1 piece, so that's it. I don't need my y-axis here. Each half of the circle is 1 piece right now.
So the first line, does that count as one of the?
Yes. So that's what breaks, the 2 pieces. So each half of the circle is 1 piece right now, and I'm going to go around 3 of those pieces negative, so I'm going to go around 3 of those pieces backwards. So 1 piece, 2 pieces, 3 pieces covered. My angle would look like this. Okay. Questions on graphing and radians? Cut each half of the circle into the denominator number of pieces, and then count around the numerator number of pieces. coterminal angles. Coterminal angles are where we added and subtracted 360. But if we're working in radians, we're not thinking about 360s. How big is a full circle in radians?
Big. 360.
360 degrees is 2 pi radians. So we're going to add and subtract 2 pi. So I'm going to take 19 pi over 3. And in this problem, I'm going to subtract 2 pi because 19 pi over 3 is very improper. That number on the top is a whole lot bigger than the bottom. But what do I need when I add or subtract fractions?
Another fraction.
Another fraction, and what has to be the same about the second fraction?
Denominator.
The denominators have to be the same. So I need to take 19 pi over 3 and subtract something over 3. What am I going to subtract over 3?
19 pi.
6 over 3.
6 pi over 3. We need to take that 2 pi and make it into a common denominator. So denominator of 3 would make it 6 pi over 3. That's still equal to 2 pi.
So you do 3 times 2.
Yep.
At that time.
So now I have 13 pi over 3. That's still positive, and just like before,
Keep subtracting.
keep subtracting. So subtract again.
Why is it 6 pi?
6 pi over 3 is equal to 2 pi. So we're adding and subtracting 2 pi, but we need a common denominator. When we add and subtract fractions, we need common denominators. And you just have to keep adding and subtracting until you get what you need. So I subtract again, I'm down to pi over 3. And subtract again, and I'm finally down to my negative solution of negative 5 pi over 3. We're adding and subtracting 2 pi over 3, or rather 6 pi over 3, because that's equal to 2 pi. 2 pi is 360 degrees. So just like we added and subtracted 360 degrees, we're adding and subtracting 2 pi. But when you work with fractions, you have to have common denominators. So 2 pi became 6 pi over 3. Subtract and subtract and subtract until we get down to our negative solution. Okay. Your homework is on the worksheet of the next page of your packet, but again, as before, do it on notebook paper so you don't have